Hello everybody, welcome to ICTS session 2 on big data analytics. Here we will discuss what the challenges you will face in implementation of Spark. Here the objective of the session 2 will be understanding the implementation in Linux operating system. Will provide a demonstration of big data analytics with PySpark using live example. We'll also learn in this session what are the alternatives to Spark, that is the Flume, Mahout, Hive and Peak that you come across. Next, we'll also learn with the big data analytics system overview with Zookeeper. So let's see how the system works. We have a local system where the Spark context has to be set up, and then we have from the local we have a cluster system where Spark worker will be there, and thus we see the Python and JVM will be working together. So this is the higher level overview. Next we come in higher level overview means that developer interacts with the Spark context object to access. This will have local file system from where the CSV files were retrieved. Python virtual machine Py4j responsible for orchestrating tasks on multiple workers in the cluster is being shown. So you can visualize what we are going to put in operational during the running of the commands. Next is the Hadoop distributed file system. File systems that manage the storage across a network of machines are called distributed file systems. Since they are network based, all the complication of network programming kick in, making the file system tolerate node failure without suffering data loss. Hadoop comes with a distributed file system called HDFS, which stands for Hadoop Distributed File System. So now let's come to what are the alternatives to Spark that we are familiar of. First is the Hive. Hive is a Hadoop based data warehousing like framework originally developed by Facebook. It allows user to write queries in SQL like language called HiveQL, which are then converted to MapReduce. This MapReduce we have discussed in session 1. Hope all of you remember. This will allow SQL programmers with no MapReduce prior experience to use the warehouse, and it make it easier to integrate with business intelligence and visualization tool such as Tableau, Revolutions Analytics, MicroStrategy, etc. So let's understand what is Peak. Peak is Latin, is a Hadoop based language developed by Yahoo. It is relatively easy to learn and is adept at very deep, very long data pipelines, a limitation of SQL. Next, let's understand what is Mahout. Mahout is a data mining library. It takes the most popular data mining algorithms for performing clustering, regression testing and statistical modeling and implements them using the MapReduce model. So what is Flume? Flume is a framework for populating Hadoop with data. Agents are populated throughout one's IT infrastructure inside the web servers, application servers and mobile devices. For example, this will help to collect data and integrate with Hadoop. So in this session, however, we will only discuss Spark, and it has a more general use case and provides higher degree of flexibility. It also helps to understand the MapReduce pattern in depth. So next, let's come to the big data analytics system. Diagrammatically, here we will understand about how the computational system existed before we went to the distributed computing with big data. So here higher level simulations application like ANSYS ran on the top of C++ code. Multiple libraries exist for that code to support complex calculations, debugging and system monitoring. So similarly, when now we move to the big data paradigm, for big data analytics system, we have virtual machines operating in cloud services, for example AWS. On the top of these servers, we have HDFS file system and then MapReduce, that is the Hadoop backend, as discussed before. So here you can see a Zookeeper is also an application level service that helps to deal with worker failure and keep all the nodes in the network in sync. So for example, in Spark, if one node fails to do its job as instructed through command, Zookeeper is notified about that node. It then reschedules that job on another node based on the availability. So next, learn what is Yarn. It is yet another resource locator. A cluster resource management system is Yarn. So Yarn applications, as you can see in the diagram, users write high-level APIs provided by distributed computing frameworks, which themselves are built on Yarn. Yarn Anatomy Resource Manager, one per cluster, manages the use of resources across the cluster. Then is the node manager. Here it runs on all nodes in the cluster to launch and monitor the container. So what is container here? What is this role? It executes an application specific process with a constrained set of resources, memory, CPU and so on. After that it comes the application master. So how to schedule the tasks through Yarn? It's a FIFO scheduler. It places applications in a queue and runs them in the order of submission. Next we have a capacity scheduler. It is a separate dedicated queue, allows the small job to start as soon as it is submitted. And next is the fair scheduler. You can see in the diagram that it will balance the resources between all. So let's come to the implementation with Spark on Linux. The installation process is very simple with Linux operating system. Prerequisite for Linux are downloaded Spark archive, PySpark pip module. We also need to add environment variables as entries. Here you can see what are the variables. We export Spark home, we then export path Spark home and PySpark Python 3. Next export Python Spark driver in Jupyter, and then we have our Jupyter notebook. So now let's come how to take the data from the Kaggle that we have already downloaded in the previous session. Right, here is a very big data which is obviously having 3.2 million rows and 80 MB data. So here you can check how is the data description. Here we'll show the description of the data. These are the carbon data with all the variables. CO is there, which we'll be analyzing. Other metrics are also there that we can analyze later. So this is about the data description that we are going to analyze. It's a very heavy data of 80 MB size of 3.2 million rows. You can see it, right? So next, let's come to the how we will use in Jupyter this demonstration by taking the paths that we use here, that is the CSV file. We have to fetch it from PySpark import, then Spark context you have to put it. After that PySpark import and SQL context we have to take it, following which we have to get the data frame, pollution data frame, then station for CO, as we will be using the CO station as a demonstration. You can use the other matrices as we have shown in the previous description, data description. So station CO, you co-filter and then use this command. After this it comes that we need to have the path of all the CSV files downloaded from Kaggle here. We then get the Spark context object, which gives us access to the Spark API. Thus we have also got the SQL context object, which gives us access to the data frame API, which will be used to load data from the CSV files. We then load the CSVs into the data frame, with the schema being what's specified in the first row of each CSV files. After that, we get the data frame as an RDD. So this is the data frame as RDD. Since we are only concerned with the CO level at each station, we do a map that keeps just those two. The result is an RDD of tuples with the first element as station ID and the next is as second element as the CO value. This makes computation for the later step faster. We then filter out all the invalid rows. The functions here returns false if either the station ID or the CO value is not specified, else it is true. All the rows for which the functions return to false are removed. As we need all CO values associated with each station together, we use the group by key transformations. This transformation, as the name suggests, group the CO values, the second values in the tuple based on the station ID, the first value in the tuple. The result is an RDD of the tuples with first element as the station ID and second element as a list or an iterable of different CO values associated with the stations. So one advice that you must take at this stage is that you check correctness of your code by looking at the first element of RDD using the first method. It should come as a tuple of station ID and a list iterable of associated CO values. Now computing the average CO values per station becomes easy. We all need to take it the sum of the elements in the CO list divided by the length of the list. The final step is to aggregate the results and send them back from each worker to the user. To do this, we can use collect method, which returns the RDD of the tuples as a list. After looking at the first 10 entries to check the correctness, we can save this onto a CSV file. So this you can use for saving into a CSV file. We are saving it as a CSV file and it will look like this. The result from multiple CSV files that were 80 MB in size, we could retrieve useful information about each station, which was of 800 bytes. That can be sent to the business to provide the business intelligence for the pollutant level ascertaining and taking some decisions. This gives insight into which station has the highest level of carbon monoxide and plan further action in future accordingly. So we come to the end of this introductory session where we show how to use big data analytics in Spark. So don't miss the subsequent session where Shijit Verma from HUKST University Hong Kong will be working into new algorithm in his final year project, where he will be mapping this big data analytics, and interesting session will be coming more after this. So thank you for being with us, and if you have any query based on the first and the second session completed now, please feel to contact us for further clarification by mailing to this email ID. Thank you once again.